Hey everyone, let me help you to explain the operation of code division multiple access, which is nothing but CDMA. CDMA is a channel access method that allows multiple users to share the same frequency bands simultaneously using unique spreading codes. So let me just break down this operation in terms of the basic principle behind CDMA is each user is assigned a unique code sequence, which is also called as a spreading code. Data is spread across your wide frequency band, and multiple user can transmit simultaneously on the same frequency operations. In order to deal with CDMA, key features are these CDMAs are self interference, which is always been minimized due to orthogonal coding. It has better security for the data which is spread across your spectrum. It also has soft handoff capability, which will provide the multipath fading along with this soft handoff. When it comes to your advantages, in that manner the increased capacity as compared with your TDMA and FDMA is being assigned with the CDMA with better spectral efficiency, improved privacy and reduced interference for that matter. The practical implementation for this CDMA is nothing but through your, it can be used for your 3G mobile communication system, GPS system and even for that matter satellite communication system. Now let's just break this whole concept of CDMA in terms of implementation. As I have already mentioned that CDMA is a channel access method which can be used by various radio communication technologies, which will simply allows multiple users to share the same frequency band by assigning unique code to each individual user. Now, as we are considering this CDMA, for this consideration, we are taking the 4 user separate spreading code which can overlay of your orthogonal code table. Let's assume that we have the channel access method and various communication technologies for the 4 user where C1, C2, C3 and C4 is being assigned. Each user can set with either 1 or -1 as their data bits. So -1 will be considered as logic 0 and 1 will be considered as logic level 1. So these bits are then spread using the unique spreading code. Now in terms of generating the spreading code, you need to have the data bits. Now we will simulate code division multiple access using Python. It's the same technology behind 3G mobile communication, and we will see how multiple user can share the same communication channel using unique codes. Let's dive into it. CDMA allows multiple user to transmit over the same frequency and that same frequency band at the same time. Each user is assigned unique codes which is in the orthogonal to the others. These are called as a spreading sequence. In our example, let's check it out. We have 4 user. User 1, user 2, user 3, user 4. So this C1, C2, C3, C4 are nothing but my 4 user. These bits are nothing but spreading codes are assigned to each individual user. So each user multiplies their data bits with their code and transmit, and at the receiver side we despread that same signal using the code of the intended user to recover their data bits. So this is the whole ideology behind the CDMA. So let's check it out step by step how the code sequence can be able to generate it for the CDMA. Now as this code is the into the Python and we are having the vector operations for individual data bits, we need to import the NumPy library. So import NumPy as a NP we need to import it to handle vector operations. Now in that manner, C1, C2, C3 and C4 are nothing but these are the orthogonal spreading codes. So each our orthogonal spreading code for 4 user are assigned with C1, C2, C3, C4, and these are being utilized with the individual data bits. 4 bits of data operations we are now able to perform it for the 4 user. If you have the 8 data bits for the 8 user, you need to change the spreading code as well as for the number of data bits here in the form of 8 bits. Now as we are 4 user with the spreading code of 4 bits, we need to have the data bits of the 4 bit size. So here 1 is represented as a logic level 1 and -1 will be represented as a logic level 0. So after this assigning of data bits, we will collect 1 bit data for each of the user. Now in order to that, after collecting the spread codes and the data bits for the each user, now each data bits are multiplied to get added with its user codes, and this is considered as your spreading operation, spreading step. So this resultant spreading step will be considered as there are multiple resultant code, resultant bits are being generated after the multiplication of data bits and spreading code will be considered as R1, R2, R3, R4. We need to combine all these spread signals into resultant channel. So R1 plus R2 plus R3 plus R4 will be considered as the combine all spread signals. Now in that manner, if we wanted to recover some kind of the data bits from that respected channel, so all we have to do is all the spread signals are added, and that is what the channel carries along with it. And if at all if we wanted to recover to the receiver side, we wanted to decode that same respected data to check it out what respected user have received that respected data bits for that matter. So for this consideration, now at the receiver side to select what user to decode, you need to assign the respected station which you wanted to listen it and recover the data from it. So we will fetch the corresponding code for the D spreading with this respected consideration of that task. So now let's run this code. We will give input data bits as a D1, -D1, 1 and D4. For that matter, what you can do is here in your online Python IDE, you can simply run this code. Very first thing, it will ask you as to enter data bits. Now as we know, the data bits will be considered as a 1 as well as -1. 1 represent logic level 1, whereas in for the -1 will be considered as the logic level 0. So right now I have entered the data bits 1, -1, 1 and fourth bit is -1. So after this, because I have already given the spreading sequence which is fixed in the form of C1, C2, C3, C4. Now resultant channel, which is nothing but multiplication of the spreading code with the individual data bits multiplication, and as per that the resultant channel output will be 0, 4, 0, 0 after the individual multiplication. Now if I wanted to recover which respected channel have received that respected data, that I have to recover it from the transmitted side to the receiver side. So for this checking purpose, now channel 2, let's say I wanted to recover the data from the channel 2. So in that manner, you just give the sequence of channel 2, and like that way you will able to check it out for what kind of sequence it is being transmitted. So right now I am selecting the resultant channel 2. So data bit recover as a -1. So you can easily check it out here. Whatever the data is been entered was a -2, and like that way is been recovered in the CDMA.